Hi guys, this is Ajit. Welcome back to the channel. So we are going to be solving today's cheat code question, which is greatest common divisor traversal. So the video is going to be very interesting. So we are going to be covering different topics, which are like four topics. The first topic is going to be greatest common divisor, and then we'll be using maps, and then we'll be using vectors, and then we'll be using graphs. So let's get into the question. So here we are given that array of nums, and then we need to find whether we can traverse all the pairs of indices which are present in the nums. So for the traversal between the indices, there are different conditions. One condition is I should not be equal to j, that is I should be always less than j, and then one more condition is the greatest common divisor between nums of I and then nums of j should be greater than 1. That means the two numbers should have common prime number present in that particular nums I or nums j. So let's take one example so that we can understand better. So the example is going to be 2, 3, 6. Here between index 0 to 1 and then 2. These are the different indices which we need to traverse from 0. So if we traverse from 0 to 1, so it is not possible by traversing from 2 to 3. Why? Because the HCF of 2, the GCD of 2 and 3 is going to be 1, and we cannot traverse directly. So we should traverse from 2 to 6, and then again we should traverse from 6 to 3, so that we'll reach 3. So after that it is done. So the traversal between 0 to 1 is done, and then let's take the traversal from 0 to 2. So we can do direct traversal from 2 to 6. Why? Because the greatest common divisor between 2 and 6 is going to be 2, so which is greater than 1. So we are going to traverse from 2 to 6 directly. So but whenever we come to 3 and 6, this is the traversal we are going to need from 1 to 2. So the GCD between 3 and 6 is going to be 3. So we can traverse from here to here. So as we can traverse from different indices which are present in the nums, we can return that it is possible to traverse between all sets of indices present in the num. So let's deep dive into what is the intuition behind this. So let's take this particular example. So num1 is going to be 6. So we are going to divide this particular number into prime numbers. Suppose let's say we'll divide it into 2 into 3. Why? Because 2 and 3 are prime numbers, and then 2 and 5. For 10 we are going to do like this, and then for 77 we are going to say 7 into 11, and then num4 is going to be 2 and 4, 2 and 7. So if we look at this particular example, so there are going to be four numbers, which is num1, num2, num3, and then num4. So whenever we have num1, so we need to traverse between 1 to 1 to 2, and then 1 to 3, and then again from 1 to 4. So these are the traversal which we need to do for this particular one. So for the 2, it is going to be 2 to 3, and then again from 2 to 4. So this is the traversal which we need to do for this particular index. So for 3, it is going to be only 3 to 4. Why? Because I should be always less than j. So these are the different indices which we need to check whether it is possible to traverse between all the indices. So let's take this particular example. So if we check this particular condition, so for one index it is going to take, like if it is I index, then it is going to take n minus 1, 2, 3. So it is going to be n minus 1. So it needs to check all the n minus 1, and then for this particular index it is going to check n minus 2, and then it is going to be n minus 3, like that. So it is going to be n minus 1 plus n minus 2 plus n minus 3 till 1. So if we do that particular operation, then it is going to be the time complexity is going to be n square. So we need to reduce this time complexity so that we can solve the solution in an optimization way. So what is the different approach we can solve this? So if we try to see this particular question, we can break the number into prime numbers. Let's say we'll break it down to 2 and 3 and then 2 and 5 and then 7 and 11 and then 2 and 7. So for this particular case, let's assume we'll visit the first number and we'll check what are the prime numbers, what are the different prime numbers. It is going to be 2 and 3. These are the prime numbers for this particular index. So we are going to store that index to prime. So it will contain all the prime factors which are present in this particular index. So it is going to be 2 and 3. So if we pick this particular prime and then check what are the numbers which contain this particular prime. So it is going to be 2 and then it is going to be 4. That means the GCD between this index and then this index and then this index is greater than 1. So we can traverse between this index and then this index and then this index. So this is the graph. This is kind of like a graph. So after this is done, so we can say that we can traverse between 2 to 4 and then we can traverse from 1 to 2 and then we can traverse from 2 to like 1 to 4. So we can, if the graph is connected, then we can say that it is possible to travel between any nodes which are present in this particular graph. So let's move to the next prime. So 3. 3 means it is there doesn't exist any index which contain 3 other than this one. So it is not going to traverse. So after that, the 3 is visited and then 2 prime is visited. So we are going to store whether the prime is visited or not in the visited prime. So whenever we come across again, let's say we'll move to the next number which is going to contain 2 and 5, which is going to contain 2. So let's pick this 2. So should we do the again traversal for this particular 2? We should not. Why? Because it is already done. It is already done by traversing between 1, 2, 4. So we should not do this particular traversal. So we'll check whether if the prime is visited, then we are not going to do the traversal. If it is not visited, then we are going to do the traversal. So we cannot do this for this particular case. And then we are going to check for this 5. So is there any index which contains 5 other than these two? No, there doesn't exist. But this traversal is done. So we are going to mark this. And then again we'll come back to 3, which is going to be 7 and 11. So for this particular 7, we'll do the traversal between 2 and between 2 and between 3 and 4. So we'll do the traversal. So for this particular case, 7 is the prime number, and then what are the index which contains this particular prime, which is 4. So we are going to do the traversal for this node. So we can say that this particular node is visited using this particular prime. So we can say that this prime is visited, this prime is visited, and this graph is connected. So as we can see that all the nodes or all the numbers are connected, then we can say that it is possible to travel between any node in the graph. So we can return true. So we'll be doing the same thing in the code. Let's go through the code. Yeah, yeah. Let's take this prime to index. It will contain all the indexes which contains this particular prime. It can be 2, 3, 5, 7, etc. And it contains all the indices which contains this particular prime. And then it is going to store from index to prime which will be using maps, so that let's say I have 1 and then again I have like 7 or 10. So instead of taking the vector of vectors, we can take maps so that it will store only some particular numbers. It cannot be very sequential. It can be sequential, but the map will help us do if it doesn't contain sequential as well. So let's take visited index. It will store whether the index is visited or not. This particular number is visited or not, and all the prime numbers in this particular nums is visited, and then it is has been traversed or not. So, and then one more thing we are going to store is whether this particular prime. Suppose if we take this particular example, so for each prime we are going to traverse. For each prime we are going to traverse. Suppose let's say for 2, it is going to traverse this 1 and then 2 and then again it is going to traverse 4. So for this traversal we need to store whether this particular prime is visited or not. So again when we come back to 2, we shouldn't do the same operation again. So we are going to store it in visited prime. So that is going to be the uh, intuition why we are using visited prime. And then this function is going to construct all the prime factors which are present in this particular nums. So let's see the construct primes. So here we are going to take all the numbers which are present in the array, and then we are going to pick one number, and then we are going to check whether this particular number is divisible by j. So this is if it is divisible by j, then we can say that this is a number which it can divide this particular number. So we can say we can add it into the prime, and then we can add it into the prime to the index, and then let's say it is divisible by 2, but it can be 2 into 2 into 2 into 2. So we should not store all the 2's. Why? Because we should store only 1 2, so that we'll store only distinct prime integers, not all the prime integers which are present. Distinct. It should be distinct. So we'll traverse through the number, and then we'll divide this particular number again and again till it is not divisible by that particular j. And then after this traversal is done, so it is going to traverse till j into j, and then it should be less than or equal to num size. Why we are considering this particular solution is, suppose let's say it is 2 3 4 and then 5 and then 6 and then 7 and then 8. So let's say 7 and 8. So we need to find all the prime factors which are present in for 8. So for this particular case, we'll consider 2, and then we'll consider 3, and then we'll consider 4, and then root of 8 is going to be like, yeah, if we say 3 into 3, which is going to be 9. So uh, we'll not be considering 3 itself. Why? Because it will not contain. If we multiply 3 into 3, so it cannot contain this particular number. And then if we move to the 4 into 4, it is already been taken by this particular number is already been taken care by this particular number. And then, yeah, so we'll not be doing the traversal for this particular case. And then let's say all the all the things are not done. Like suppose let's say we do not have any prime number which is present in this particular numbers which we can divide to prime factors. So, so at that particular time we can say that temp is itself a prime number. So we are going to add this temp into the index to prime and then prime to index. So it will store all the prime numbers and then indexes which contains that particular prime number. So that is a function for constructing the prime factors. So and then we'll be moving to the next thing, which is doing the DFS traversal. So this DFS traversal is going to take it is going to, we'll start from 0th number, and then we'll see whether it is possible to visit all the nodes which are present in this particular array. So how is that possible? Let's say, let's take this particular example. So let's take this particular example. So we'll pick this two. So after picking this two, we'll check whether this two is visited or not. It is not visited. Two is not visited. So we'll take this particular index and then move to the other index which contains this particular prime. So it will move to this particular, we'll check whether this 2 is visited or not. So as this is not visited, so we are going to visit this particular 2, and then we'll move to the next iteration, which is going to be next index, which is 2. And then again, if we come to this particular index, we'll check whether this is visited or not. Yeah, this is visited already. So we'll not go through this particular loop, and then we'll see, and then we'll move to the next 5. So 5 will is not visited, so 5 will be visited, and then there are no indexes which contains the 5 other than 2. So this will stop here, and then again it will come back to here, and then this index is done. This index is done. This index is done for this particular prime number. But there is one more index which is this index, which is 4. So we are going to visit this particular number, and then we'll check this 2 is visited. Yes. So we are not going to traverse based upon this prime, and then we'll move to the next prime, which is 7. So this 7 is not visited. So we'll mark 7 as visited. And then there is one more index which contains this particular prime, which is 3. So we'll move to this particular index, and then we'll mark this node as visited, and then all these nodes are visited, as like we visited all the nodes, so it will contain all the nodes are visited or not. So that is how we are going to do the traversal. So we'll check whether this particular index is visited or not. If it is visited, then you don't need to do the traversal, go back. If it is not visited, then we are going to visit this particular case, and then we are going to pick each prime, and then again we'll check whether this prime is already been visited. If it is visited, then you don't need to take care. The other case which is already been done, it is going to take care. Now we are going to mark this particular prime as visited, and then we'll move to next step, which is we'll pick each index which contains this prime, and then we are going to check whether this index is visited or not. If it is visited, then we are going to continue. If it is not visited, we are going to do the again DFS for this, and then it will keep on doing the DFS. So after the DFS is done, we need to check whether all the nodes are visited or not. So we are going to write this particular all visited function, which will check whether this all the indexes are visited or not. If it is not visited, then we are going to return false. Yeah, that's all for this video. And then if we check about the time complexity, so the time complexity is going to be, for this, if we take n, and then for this particular case we take m, then it is going to be n root m. And then if we see the space complexity, as we are taking like n and m, and then m, it is going to be n plus m. Yeah, that's all for this video. If you like the video, like the video, and then if you did not subscribe the video, just do the subscribe button. Thank you.